At equilibrium, which statement about reaction rates is correct? The forward rate is greater than the reverse rate. The reverse rate is greater than the forward rate. Both rates are zero, or both rates are equal and non-zero. The correct answer is both rates are equal and non-zero. Reactions are still happening, so the rates of reaction are non-zero. However, they happen at the same rate, which is why the system is at equilibrium. So both rates are equal and non-zero. Which observation indicates that K is smaller than 1? Products outnumber reactants. Equal numbers present for all species. Reactants outnumber products, or no particles are visible. The answer is reactants outnumber products, because a K value that's less than 1 indicates a greater proportion of reactants compared to products in the reaction mixture. A value of K greater than 1 would indicate a greater proportion of products compared to reactants. For the salt CaF2, which expression represents its solubility constant, Ksp? Concentration of CaF2, concentration of Ca2 plus multiplied by the concentration of F minus, concentration of Ca2 plus multiplied by the concentration of F minus squared, or the concentration of Ca2 plus squared multiplied by the concentration of F minus. The answer is the concentration of Ca2 plus multiplied by the concentration of F minus squared, because there are 2 moles of F minus ions for every 1 mole of Ca2 plus ions, meaning Ksp equals concentration of Ca2 plus multiplied by the concentration of F minus squared. Now, which species is excluded from the expression for Qc or Kc? A gas, an aqueous ion, a pure solid, or a dissolved molecular compound? The answer is a pure solid, because solids are excluded from Qc and Kc expressions because their concentrations remain constant. More precisely, it is actually their activities that are constant, but at this level of study, activity is taken to be proportional to concentration. So in an answer, you can just refer to the fact a solid's concentration effectively remains constant. Now, which value of K corresponds to a reaction that barely proceeds? K equals 10 to the power 6, K equals 1, K equals 10 to the power minus 8, or K equals 10 to the power 2. The answer is K equals 10 to the power minus 8, because the greater the value of K over 1, the more the reaction proceeds in the forward direction. However, the smaller the value of K under 1, the more the reaction proceeds in the reverse direction. So a very small proportion of products compared to reactants are in an equilibrium mixture. At equilibrium, for the reaction A going to form B, the concentration of A is 0.4 molar and B 0.1 molar. What is Kc? 0.25, 0.40, 2.5, or 4.0? The answer is 0.25, because to calculate Kc, we take the concentration of B and divide it by the concentration of A. 0.1 divided by 0.4 gives 0.25. Now, which observation indicates that a system is moving towards equilibrium but has not yet reached it? Concentrations of species are changing with time, the forward and reverse reaction rates are equal, no observable change occurs, or the system is closed. The answer is concentrations of species are changing with time, because if a system is at equilibrium, then the concentrations of all species remain constant. So if the concentration of species are changing, that means the system can't be at equilibrium. At equilibrium, which relationship between reaction quotient Q and the equilibrium constant K is true? Q equals 0, Q is less than K, Q is equal to K, or Q is greater than K? The answer is Q equals K. A system at equilibrium is disturbed, so now Q is greater than K. How will the system respond? By forming more products, by forming more reactants, by increasing the value of K, or by decreasing the temperature? The answer is by forming more reactants, because a Q value that's greater than K means the proportion of product concentration to reactant concentration is greater than when the system is at equilibrium. So, to return to equilibrium, the product concentration must decrease by forming more reactants, until the Q value equals K. For a gas phase equilibrium, which stress can be analyzed using Le Chatelier's principle only if temperature is held constant? Addition of a catalyst, change in volume, change in temperature, or change in activation energy? The answer is a change in volume. The use of a catalyst has no impact on positions of equilibrium, only the rate of attainment of equilibrium, and change in temperature would mean temperature isn't being held constant. Which ion is considered the common ion when CaCl2 is added to a solution of CaF2? Ca2 plus, Cl minus, F minus, or OH minus? The answer is Ca2 plus, because the calcium Ca2 plus ion is present in solutions of both calcium chloride CaCl2 and calcium fluoride CaF2, so the common ion between the two would be Ca2 plus. A student calculates Kc equals 1.0 for a reaction. What does this indicate? Products are favored at equilibrium, reactants are favored at equilibrium, reactants and products are present in comparable amounts, or the reaction does not occur. The answer is reactants and products are present in comparable amounts. Because remember, the equilibrium constant Kc is a comparison of the ratio of concentration of products for the forward direction compared to concentration of reactants in the equilibrium mixture. The greater the value of Kc over 1, the greater the proportion of products compared to reactants, and the greater the value of Kc under 1, so the smaller the value of Kc, the greater the proportion of reactants compared to products. For a reaction where Q is greater than K, what must occur before equilibrium is reached? Net formation of products, net consumption of reactants, net conversion of products to reactants, or no net change in concentrations. The answer is a net conversion of products to reactants. Because a larger value of Q compared to K means the reaction mixture contains a greater proportion of products compared to reactants than for the system at equilibrium. This means some of those products must be converted into reactants to make the value of Q smaller and therefore equal K. Why does a change in concentration not permanently change K? K depends on initial concentrations, K depends only on temperature, K depends on the mechanism, or K depends on reaction rate. The answer is K depends only on temperature. The only thing that will change the value of K for a particular reaction is changing the temperature. K is temperature dependent. For a reversible reaction at constant temperature, which statement is always true when the system is at equilibrium? Q is greater than K, Q is smaller than K, Q equals K, or Q equals 0. The answer is Q equals K, because Q, the reaction quotient, refers to the proportion of product to reactant concentrations at any given moment in time, whereas K refers to the proportion of product to reactant concentrations at equilibrium. So if Q is the same as K, that means the proportion of product to reactant concentrations must be the same as when the system is at equilibrium, meaning the system is at equilibrium.